Good morning, everyone. So, today we will continue with our discussion on optical isomerism. In the previous class, we tried to define what we mean by optical isomerism, according to which we defined optical isomerism to be a phenomenon in which stereoisomers are able to rotate plane polarized light by a certain angle. So, such phenomenon of optical isomerism is actually shown only by molecules which possess the property of chirality, that is, non-superimposability of the mirror image. In organic molecules, chirality could be exhibited only by 3D molecules. That means those molecules which have which can spread over the three-dimensional space. Okay. So, such three-dimensional shape is possible only in case of saturated molecules, because when we started with our discussion on the basics of organic chemistry, I talked about alkane, alkene and alkyne, where alkenes are a kind of a two-dimensional structure and alkynes are a kind of linear structure. So they both do not have a three-dimensional spread over the space. So that means the only left type of molecule is the saturated molecules, and we know that in organic molecule, the saturated system in that carbon atom will have a hybridization of sp3, and sp3 is nothing but a tetrahedral shape. Okay, so what we are going to today see is how to represent a 3D structure, because every time you cannot use a model in order to understand the 3D spread over the space. So we require some kind of way to represent a three-dimensional object or a molecule on a two-dimensional plane. Okay, so how do we do that? For representation of a 3D on a two-dimensional plane, we use two different formulas, and that is perspective formula. One is the perspective formula, another is your Fisher projection formula. These are the two formulas that we are going to learn how to draw so that we can easily represent a three-dimension on a two-dimensional plane. So we are going to learn today how we are going to draw it. Okay. So let's start with the simplest molecule, and that is your methane, the major component of your compressed natural gas, that is your CNG. Okay. So when you usually, till now, when you have been drawing, you drew the methane molecule like something like this. Okay. But in actual, if you ask me whether this is a correct way of representing a methane molecule, then I would say that it is a wrong way. If you want to represent your methane molecule something like this, then you probably have to show its three-dimensional effect. That is, these form the vertices of a regular tetrahedron. Okay, so if you draw a tetrahedron, okay, in this, and then you show this structure, then probably we can imagine that this carbon is at the center of the tetrahedron, and at each of the vertices of the tetrahedron, you have the hydrogen atom. Then I can imagine this to be a tetrahedral structure. That means this is having a three-dimensional spread over the space. Okay, so just by simply drawing the lines, 4 lines attached with hydrogen over the carbon doesn't mean. Okay, so how do we try to draw every time to draw a tetrahedron around this carbon atom won't be such an easy job, and if we have many complicated substituent attached apart from the hydrogen, then there can be more complication to draw a tetrahedron every time. So we require to make this more simpler. Okay. For that purpose, we will start with how to draw the perspective formula. Now, in perspective formula, usually you have like if you draw a simple line like this, Okay, just simple line. Line varachikkana. What do you mean by that? It means it represents the bonds on the writing plane. That means on the plane of the board. Suppose this is my writing plane, that is the board. On that, if I draw like this, that represents the bonds that are on the plane of the board. Another type of way of representing the bond is solid wedge. Okay, solid wedge is nothing but if you draw something like this with a shading like this. Okay, then that represents the solid. Solid wedge represents bonds that are above the plane of the board. Okay. Then another type of bonding is your dash wedge. Dash wedge is nothing but if you draw the bond something like this, then those represent the dash bonds. Okay. Dash bonds represent those bonds that are below the plane of the board. Okay. And the point of intersection of all these bonds is what you call as the carbon center. The carbon is represented by the point of intersection of all these lines. Okay. So let us look into using these particular bonds, how we draw the molecule. Okay, we are going to look now into that particular thing. Okay, so if we are talking about methane molecule. So I have here a model of methane molecule. So this is the carbon with all the 4 hydrogen atoms attached to it in a tetrahedral fashion. Okay. Now I am going to represent this methane molecule on a using a perspective formula using the lines, solid wedge, and the dash bonds. Okay. So in perspective formula, the lines represent the bonds which are on the plane of the on the writing plane, and solid wedge represent the bonds that are above the plane, and dash wedge represent the bonds that are below the plane. Okay. So if I place my molecule something like this, okay, and suppose this is the plane over which these 2 hydrogens are contained. Okay, so if you place a plane somewhere passing through this CH bond and passing through this CH bond, something like that, if you place a white sheet like this, so that these 2 bonds are kind of on the writing plane. Okay, so these 2 bonds are on the writing plane. If these 2 bonds are on the writing plane, one of the hydrogen here is above the plane and one of the hydrogen here is below the plane. So that is why I drew now a perspective formula in which I have drawn 2 hydrogens on the writing plane, and 1 hydrogen is coming out and 1 hydrogen is going down. I represent it with a dash mark. Same thing I can represent in another fashion. Suppose if you see this, now how you can view the 2 hydrogens here are on the writing plane. Suppose this is the plane of writing my hands. Okay, on this writing plane I have these 2 CH bonds. If that is the case, if these 2 bonds, this CH bond and this CH bond are on the plane of or on the writing plane, then one of the hydrogen is coming out and one of the hydrogen is going inside the writing plane. So that is why I showed one of the hydrogen as solid wedge which is coming above the plane, and one of the hydrogen which is a wedge which is going inside the plane. So another way of representing using these lines and wedges is that if I represent my molecule something like this. Okay. Now here I did not use any lines. Only what I have used is the solid wedge and the dash wedge. Can you visualize now how this 3D dimension should be looking like? So here the two hydrogens are above the writing plane. Okay, so I should be placing my writing plane somewhere passing through the middle of this. Okay, middle of this, and then you can see the two hydrogens are on the front of the writing plane, and the two hydrogens are pointing behind the writing plane. Okay, so that is why the two vertical CH bonds are pointing backside, and two horizontal CH bonds are pointing towards the front side. So you can hold the molecule like this, and you will see this particular diagram clearly visible in the three-dimensional plane. So what I would like you to do is get hold of some matchsticks and try to make a tetrahedral structure like this. Okay? And then try to visualize these diagrams yourself. Okay. So I'll continue with the drawing of these particular other molecules also in the coming lecture. So just concentrate on the perspective formula and try to understand these two way of representing using wedges, using solid wedges or lines. Okay, whatever way you imagine. Try to draw the methane molecule and try to visualize these 2D representation correlated with the three-dimensional model. So get hold of some matchsticks, 4 matchsticks, and try to make a tetrahedral structure like this, and then try to visualize this and make this. So this is your work for today. Make the methane structure and the corresponding perspective formula. So today we only looked into the perspective formula. The simplest one is methane. This perspective formula is also called by another name called flying wedge formula. Flying wedge formula, or they are also called as wedge dash formulas. Okay, so just practice over this. We are going to in the next video, I'll be discussing about how to draw these structures as well. Once we are through with the perspective formula, we will go directly to the Fisher prediction formula. So thank you very much for your patience listening.